is of three types. Line charge, aerial charge and volume charge. Okay. Aerial charge, volume charge. Density represented by rho, sigma, lambda. Line charge, if a wire is like this, positive is charge is given to it, it will produce electric field in this direction. In 3D, if you can understand this, this means in all direction it is producing electric field. Compiling all the electric field, the structure formed by the electric field line would be like this, a cylindrical system. Like this. Aerial charge density would be like this. Let us just be a sphere. Charge is given to it this way. Electric lines field would be like in somewhat this way. This is aerial charge density. Next is volume charge density, means inside the body. Charge is like this. Formula for these three is lambda equal to charge upon में unit length. Aerial charge sigma is equal to q upon में area of that body. Like this is a sphere, therefore it would be 4 pi r square. Similarly, rho is equal to q upon में volume. Volume is body sphere, therefore volume of sphere 4 by 3 pi r cube. Next comes properties of conductor and insulator. As I have earlier told you the difference between the conductor and insulator, it is a property of material whether through which it allows current to pass through it or not. Now, the property shown by the conductor is electric field shielding. Let me show this phenomena to you. As you know, these electric field would be perpendicularly originating in this way. Perpendicularly means perpendicular to the surface. As it is a conductor body, electric field inside the conductor is 0. Means if we put electric charge inside this या फिर any other body inside this, it will not be influenced या फिर it will not experience force due to electric field produced, electric field present outside the system. As electric field in the sphere is 0. Next comes electric flux. Flux is nothing but, if we say that how many electric field lines is passing through it, this is flux. एक जगह से कितनी इलेक्ट्रिक फील्ड लाइंस पास हो रही है, दैट इज फ्लक्स. फ्लक्स इज अ स्केलर क्वांटिटी डिनोटेड बाय phi. Denoted by phi. Phi is E dot A, dot product. E dot product of A equal to, can be written as EA cos theta. As you know, dot product gives scalar quantity, therefore flux is also a scalar quantity. This is vector, but due to dot product, electric flux is scalar quantity. Like, let this be a square. Now the aerial vector will be perpendicular to this surface. Means in this way. This is aerial vector perpendicular to the surface. Means if this is an xy plane, the aerial vector will be in z-axis. As we can see, the flux is cos theta component, means the theta between the aerial vector and the electric field. If the electric field is passing in this way, now as you can see, the electric field is perpendicular, means in z axis only. The theta between the aerial vector and the electric field is 0, as electric field is also in z direction and the aerial vector is also z direction. The angle between the electric field and aerial vector is becomes 0. Now the cos 0 is 1, means electric flux will be equal to EA. But in case if the electric field is not like this way, let it be in this direction, means parallel to the plane of surface, maybe in x-axis or y-axis, but in parallel to the plane, means the angle between the electric field and aerial vector would be 90 degree. Cos 90 is 0, means the flux passed will be 0. Theta, the angle is the angle between aerial vector and the electric field vector. Question: let the aerial vector given to you is A1 I cap, A2 J cap plus A3 K cap. Electric field given to you is E1 I cap plus E2 J cap plus E3 K cap. Now the question is to find the flux through it. As you know, the flux is nothing but dot product of A dot B. As you know, it is a dot product. There is not necessarily A dot B is equal to B dot A, can also be written as. Therefore, as you know, dot product is a scalar quantity. Therefore, the dot product can be seen as this, means A1 E1 plus A2 E2 plus A3 E3. This will be the flux. Now coming to the next part, that is Gauss law. Gauss law is nothing but the law which states that flux passing through any closed surface is equal to Q enclosed upon में epsilon naught. Means flux is equal to Q enclosed upon में epsilon naught. Means if we have some charges like Q1, Q2, Q3, Q4, Q5. If we draw a Gaussian surface like in this way, if we in this way, now this is a closed surface. As you can see, I have made closed, known as Gaussian surface. Alright. The flux induced will be due to the enclosed Q, means the charge present in the Gaussian surface, not due to the outside. But the electric field produced will be due to all charges, whether inside or outside. But the flux produced will be due to the charges present only inside the Gaussian surface. Gaussian surface must be a closed surface of any shape or size. It can be of any shape and size. Gauss law is true for any closed surface, and also this is the Gaussian law. Also, as I have told you earlier, flux is equal to Q enclosed upon epsilon naught. It can be also written as E dot A. Gaussian surface discrete surface से pass नहीं कर सकता. Means like if I have drawn Gaussian surface in this way and charge is present here, अब ये Q के से पास होकर जा रहा है, ये डिस्क्रीट सरफेस से पास नहीं हो सकता. दिस इज इनकरेक्ट. With the help of Gauss law, we can calculate electric field of some special electric system. Finally, Gauss law is based inverse square dependency of distance. As we have seen Coulomb's law, if there is any violation in the Gauss law, it means that departure from Coulomb's law also. So, what we have studied till now, we have seen electric charge, how electric charge is produced, the difference between the conductor and insulator, charging of body, basic properties of electric charge, Coulomb's law, rule of Coulomb's law, principle of superposition, electric field, uniform non-uniform electric field, charge densities, electrostatic shielding effect, electric flux, dot product, Gauss law. And now next come to the next part of this chapter, that is